Hello guys, welcome back to our video. So in this video now, after taking like the corner cases of reflection, we're gonna now take the general case. If we want to reflect around any line with any arbitrary like slope, okay? So number 5, let's do it as a case. Number 5, reflect 1 still about the line y equal to mx. M can be -1, M can be 1, M can be 0, infinity, And yes, there is like lines that has infinite like slope, like for example, the y-axis, because tan theta, like the angle between the y-axis and the x-axis is theta, 90 degrees, and tan 90 is actually infinity, okay? So that's basically all the 4 cases that we take so far as a corner cases. This is a general case, okay? This is the general case. So it's a little bit tricky to do that, but but there is a way to do it, like, and it's doable. It just needs some like little imagination from you, like but it should be doable and easy to understand. Just to follow the lecture. Okay, so let's imagine it, and see how we're gonna approach that to achieve like this general like reflection. So assume this is our axis here, x and y. Y and x, okay? And let's assume this is, for example, the vector, like x and y, vector called the v, has two coordinate x and y. And we want to reflect it around like a line called ymx. This is y equal to mx. Okay. We're gonna assume that the angle between the ymx and x is theta, for example. So that's basically theta. And the angle between ymx and the vectors that we want to reflect is, for example, phi, okay? Or phi, whatever they call it. Good. So what we wanted to do is to reflect, about y equal to mx. So what we do in reflection, we make like a perpendicular line. So that's what we're going to do. Like that. And we extend it with the same distance. So that distance should be equal to that distance here. And that will be this red line here. This x, and 1, for example, y1 is our reflection. And we wanted to find x1, y1. We wanted to find the matrix that's going to give us x1, y1. So there's a scheme, an algorithm, like a way, a method to do that. So we're going to do that in actually 3 steps or 2 steps. We're going to find out right now. Okay? So bear with me, and let's see how we will do that. Okay. So let's go back to our original file. Okay. So the first step is to rotate clockwise direction with an angle theta. Okay. So the first step, number 1, step 1, rotate everything. Rotate like the ymx and also the vector v with clockwise direction with angle theta. So clockwise direction with angle theta. What is the angle theta? It is the angle between ymx, y equal to mx, and the x-axis. Okay. So let's apply. If we apply this step, that's what we're gonna get. So if you rotate y equal to mx with an angle theta clockwise, what's gonna happen? It will coincide with the x-axis, right? So that will be, let's do it with, for example, red. So that will be y equal to mx. Okay, m now is 0 because basically y, equal to 0 all the time on the x-axis, right? Where will be the new location of the vector v? It will be still with a phi angle from or underneath the y equal to mx. So this will be our vector, and still this is part. Okay. So the first step, we multiply the vector v with rotate with angle theta clockwise. Okay. That's the first step. Second step, step 2. Let's go back to our normal color. Step 2. In step 2, what we're gonna do is as follows. We're gonna reflect around the x-axis. We're gonna reflect the vector, v around x-axis. Okay, reflect v, the vector v, xy, about the x-axis. Remember, the x-axis now is coincide with y equal to mx. Okay. So let's see the result if we do that. Actually, we're going to reflect everything, even y equal to mx. But since we are reflecting y equal to, which is now m equal to 0, and we are like with the x-axis, it will be the same, right? But the mirror now is our x-axis. So this is y. Here is our x-axis. So in the second step here, y equal to mx will be the same, because the mirror is this one here. That's the mirror that we reflect about. And v, the vector v will be reflected. So let's write it before and let's draw it before and after. So this is before. I'm going to do it with another color. This color, for example, this is before. That's v. So we're going to extend like a perpendicular line, extend it further to the same distance. And that's the reflection. So let's do the reflection with red. That's the vector v after the reflection. Okay. So let's now represent that mathematically. So this v here, remember, it's actually come from that one. It is a rotation from the original v, right? So now we're gonna do a reflection. Remember, we equalize the reflection. This is as q, rotation as r. This is the reflection, so it's q. This is the reflection around x-axis. To whom? To r theta clockwise of v. So we multiply now v with two matrices. We still, and still, of course, this is phi, and this is also the angle phi. Still the same angle phi. Okay. Step 3, which is the final step. Let's now just go back and reflect. So what happened here? So this vector, which should be the final result that we all desire and want, okay, has an angle phi or phi with y equal to mx. That's very good. Now let's like rotate. If we rotate everything now, so y equal to mx, which is now still on the x-axis, and the new location of vector v, if we rotate everything with an angle theta counterclockwise, what's going to happen? So everything will go in that direction with an angle theta. Okay. So what is this angle here? This big angle. Let's do it with another color. So this big angle, let's do it like with orange. This big angle here, it's actually theta plus phi plus phi. Okay. Good. So if we rotate that vector v, which has currently an angle phi with an angle theta, so it's here now with an angle phi. We're gonna rotate it with more with angle theta. So the total angle will be theta plus phi, which is basically that one. Okay, that's what we're gonna do in step 3. So in step 3, we're gonna rotate everything counterclockwise with an angle theta. Step 3, rotate the vector v and y mx as well. Not about, this is rotation with angle theta counter clockwise direction. Okay, counterclockwise. Okay, so that's basically the axes, x and y. Okay, I'm gonna do everything here. So let's do both y equal to mx and v. So y to mx now is just coincide with like lies over like the x-axis. So it's go up with angle theta. Like it will go basically to its original position. So its original position has an angle theta here. Right? This is angle theta. So it will go to its original position. Let's write approximately. Yeah, okay. Like that. Y to mx, and that's an angle equal to theta. Okay. And this guy V, okay, has an angle phi now. In that case, it's gonna add up. It's gonna rotate now with an angle theta. So its angle from the x-axis will be phi plus theta. So it will end up here. Okay, and that's here phi. So that the total angle here is phi plus theta, just as what we wanted in here. Okay, so let's now translate that into mathematics. Okay, so remember that v here is actually represented by this multiplication. Q x-axis are theta clockwise v. Okay, so we're gonna take all of that and we multiply it by rotation matrix of angle theta counterclockwise. So r theta counterclockwise multiplied by q x-axis multiplied by r theta clockwise v. Okay, and that's our final answer here. So our final answer here, to make the reflection around y equal to mx, is actually three matrices. Okay, so the reflection matrix QYMX, the reflection matrix that will reflect a vector around y equal to mx equal to q x-axis, a reflection around x-axis. I'm sorry, first rotation with angle rotation r theta clockwise, counterclockwise, multiplied by reflection matrix around the x-axis, multiplied by r theta clockwise. Okay. Once we know each one of these matrices, then we could found basically our like the destination basically, which is like q y equal to mx. So let's find them. So q y mx equal to r theta counterclockwise. Remember, we know r from our previous like lesson, cosine theta minus sine theta, sine theta, cosine theta. Okay, so basically we're gonna just put it, as it is. So cosine theta minus sine theta, sine theta, cosine theta. Okay, we take before q x-axis, the reflection matrix around the x-axis. So I have here the answer directly. Let's not waste our time. So 1 0 is 0 minus 1. You can just, guys, go back to our previous video and you're gonna find it. And yeah, this is maybe like a little bit tricky. So now r theta clockwise. Okay, so we want to move. Let's do it like we want to move a vector. Let's, for example, this is the vector. For example, we want to move theta counterclockwise. So that will be its equation. Okay, that's basically equal to moving in that direction counterclockwise. So what is this big, very big angle here? It is 360 degrees minus theta. Okay, so it will be cosine 360 minus theta. We need some space here. Yes, that's the angle here. Sine minus sine 360 degrees minus theta, then sine 360 degrees minus theta, and here is cosine 360 degrees minus theta. Okay, good. So let's first multiply these together. If we multiply these together, this will give us cosine theta. I have the solution, you guys can check on me, that's fine. Sine theta minus cosine theta. And this matrix here, cosine 360 minus theta, that will give us cosine theta. And this will give us sine theta. This will give us minus sine theta. And this will give us cosine theta. Okay? Now let's call, just for simplicity, let's call cosine theta equal to C, sine theta equal to S. Okay, we know the angle is theta, so that's fine. So that will be, let's multiply them together, C square minus S square, 2CS, and here S square minus C square. Remember, S square means sine square theta. C square here means C square theta. Let's even write it. So C square is equal to cosine square theta. S square is equal to sine square theta. But just for simplicity, let's write it in this way. Okay. Now, what is cosine theta and what is sine theta? Can we know that? Yes, we can know. We're gonna draw again the axes, the x and y axis. And we're gonna find them in terms of mx slope. Okay. So let's assume this is y equal to mx. Okay. And we're gonna take like a unit length on the x-axis. So let's assume this is 1. Okay. Distance here. And we're gonna go up. And we have here like a right a triangle with a right angle. Okay. So if this length is 1, then this should be m, because the slope is like because this is an angle theta, the slope is basically the side in front of the angle on the divided by the side to the angle itself. Okay, so it's m divided by 1. So cosine theta here, let's even continue here. Cosine theta here is basically m, and for this the length of the hypotenuse here will be 1 plus m squared. Will be 1 divided by 1 plus m squared. What is sine theta here? It will be m divided by 1 plus m squared. Okay. So we know the sine theta and the cosine theta. So basically, so y qy equal to mx equal to, let's now compensate here. So c square, let's even write it clearly, then we compensate later. C square will be 1 over 1 plus m square minus, of course, 1 square is 1. S square will be m square divided by 1 plus m square. 2cs. So this is 2m divided by the square root will be multiplied or squared, so it will be 1 plus m squared. 1 plus m squared. So 2m again, 1 plus m squared. S squared, so this will be the opposite here. So m squared divided by 1 plus m squared minus 1 plus 1 m squared. So now we can take 1 over 1 plus m squared as a common factor. Okay, so let's do that. So q y equal to mx equal to 1 over 1 plus m squared. Here we're going to have 1 minus m squared. Here we're going to have 2m. Here we have 2m. Here we have m squared minus 1. Okay, that's basically the general, reflection matrix. Now, to know if this is correct or wrong, we should apply, or we should check with our corner cases. Okay, y equal when m is 0, 0. No? When m is 1, when m is minus 1, and m is infinity. Okay, so let's start by the first case. The first case that we studied here, number one, is basically reflect about y-axis, which is equal to x equal to 0. So y-axis has a slope equal to infinity. Okay. So of course we cannot like compensate infinity directly into that equation. We have to do a limit. So number one, reflect 1 1 around or about y-axis. The y-axis, y equal to infinite x, because the angle between the line and the x 90. So tan 90 the infinity. Okay. So the q here, y-axis equal to limit m approximately to infinity. And it's better to compensate here in that equation. So we divide by m squared. So 1 m squared, 1 over m squared plus 1 minus. You can have 1 here, 1 over m squared plus 1. Then same here, divided by m squared, so 2m over m squared, 1 over m squared plus m squared over m squared. This is how you do it. I know you might haven't seen this before. You might not have this seen before, so please follow up or like check later. But this is the correct way to do it. So 2m divided by m squared, 1 over m squared plus m squared over m squared, which is 1. Here you can have something like that. 1 over m squared plus 1 minus 1 over m squared, 1 over m squared plus, yeah. Just what I did is basically I divided by m squared, like numerator, denominator, in all the terms. Okay. Now you can now compensate with m equal to infinity. So when you do that, that will be 0. That term here, I know just 1 over m will be 0. So this guy totally will be minus 1. So that's equal minus 1. That guy will be 0. So all that term will be 0. All that term will be 0. So we have 0 and 0. Now, this term alone will be 0, but we still have 1 and 1. So 1 over 0 plus 1, which is 1. Minus this guy will be 0. That will be it. It's now check. We have minus 1, 0, 0, 1. Minus 1, 0, 0, 1. Minus 1, 0, 0, 1. Minus 1, 0, 0. That's correct. Right? Someone might be confused, okay, because m here is infinity. He might not be convinced, Is there any way? Is there any way to do it? Yes. You still have, this formula here. Okay. Remember, c squared is cosine theta squared. Okay. Cosine square theta. Cosine square 90. So we can still do it. So let's do that. Take it down here and put theta equal to 90, just to be like parallel to this one. So this will be cosine square 90 minus sine square 90, 2 cosine 90 sine 90. Here 2 cosine 90 sine 90. And sine square 90 minus cosine square 90. Okay, cosine 90, cosine square 90, cube 90 is all 0. Sine square 90 means sine 90 multiplied by sine 90. 1 by 1 is 1. So that guy will be 1. Cosine 90 is 0, so it will cancel out everything. So we're going to end up with minus 1 here, 0 here, 0 here. Then sine square 90, again sine 90 multiplied by sine 91 multiplied by 1 is just 1. And cosine 90 is 0. So that will be 1. Just to compare them to each other, that's okay. So if you don't like the limit, you are not convinced that m equal to infinity, You have the other way. Okay, good. Now, number 2. 2 and 3 and 4 is very easy. Number 2. What we have on number 2 here reflects around x-axis, y equal to 0. Y equal to 0x, basically. Okay. So, x-axis reflection around x-axis, y equal to 0, x 0. That means m equal to 0. Just remove the m and put 0. Okay. So let's do that. So 1 over 1 plus m, 1 plus 0, it will be 1. Okay. And 1 minus 0, 0 is 2, 0 to 0, and 1 minus 1. Okay. That's equal. This is, of course, 1. So it will be 1. Of course, 2. This is not 20. This is 2 multiplied by 0. So 2 multiplied by 0 is 0. 2 multiplied by 0 is 0. 1 minus 1 is 0. So that's the cube. 1 and 3 zeros. Let's check if this is correct or wrong. So 1, 0, 0. Number 2. No, we have a mistake here. X-axis. So x-axis, y equal to 0. Oh, wait, we have a mistake. Check where it came from. Equal to 0. Oh, yeah, I'm sorry. Yeah, m is equal to 0, so that's 0. Okay, that's 0. So this will be minus 1. So 1, 0, 0 minus 1. 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 Okay. Okay, check number 3. Reflect. Okay, around, I believe, y equal to x. Y equal to x. So m is equal to 1. Okay, so q, check here. So, okay, m will be equal to 1. So q will be equal to 1 over 1 plus 1 squared, which is 1. Then 1 minus 1. Then we have here 2 multiplied by 1. 2 multiplied by 1. Then we have m squared minus 1, so 1 minus 1. So q will be equal to half. That's 0, that's 0. And 2, we can multiply the half inside, so that will be 0, 1, 1, 0. 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, correct. Finally, number 4. Number 4, reflect y equal to minus x means m equal to minus 1. So I'm going to do the same again. So q 1 plus m squared minus 1 squared is just 1. That's okay. 1 minus m squared, 1 minus 1. 1 squared is 1. Then we have 2m. 2 multiplied by minus 1. 2 multiplied by minus 1. Then we have finally m squared minus 1, which is 1 minus 1 again. So q equal to half. 0, 0. Minus 2 minus 2. That's basically 0 minus 1 minus 1, 0. Let's check number 4. 0 minus 1, minus 1, 0. 0 minus 1. Yup, minus 1, 0. Okay, guys, that was it for this video. In the next video, I'm going to take an example, very important example. And we're going to see how to apply, this concept here of this general formula to find the reflection. Thank you very much for watching and see you in the next video.